So good morning everyone. Let's continue our discussion. Today we'll talk about how to write a very first example in your Spark. Okay. And as the industry standard, we always teach the simple word count example to get started with Apache Spark, right? So here also we'll do the same thing. We'll try to focus on how to write a small code to count the words given in a file, right? Word wise counts. For example, apple, how many times, ball, how many times, cat, how many times. And over the period of time, as we move on with the complete course, right, we will look into very sophisticated examples. We'll learn everything step by step. Now, today our agenda is on word count. Okay, so let us assume you have got a word count.txt file in some location. It could be D drive, dataset, folder, or in any folder. Okay, let us say you have got a word count file, and that file structure looks something like this. It's something like this. Let's say we have apple, we have ball, we have again apple, we have apple, and so on. Some sort of words all together, right? Now if I say this is my file, okay, now I want to execute my code in such a way that it should give me the output like apple is present 1 2 3 times and ball is present 2 times. Okay, now if I ask you to write the same thing in MapReduce, you'll have to write a mapper code. You have to emit word one like apple one, apple one, apple one, and in the reducer to aggregate them together and start counting it. Similar thing we also do here in a Spark, but the only point is you don't have to write a separate map or you don't have to write a separate reducer. Everything works just like a function call. Okay, so that makes our Spark super fast to develop as well, not just to execute, but super fast to develop as well. Again, now this is our agenda, right? So you may ask me, hey, this looks a very small file, and why will I use Spark to just write this code? Can I not do that using a Java, code, or can I not just write that using a simple Python script, or can I do the same thing using Scala? Of course, you can do that, right? But here the agenda is not just to solve a word count for a small file. Tomorrow, if this file is around, let's say, 10 terabytes, your same code should work with no changes at all, right? Your same code should work without any changes. Tomorrow, if I have so many files like word count 1.txt, word count 2.txt, word count 1000.txt, right? The same code should work on all the files parallelly without the code changes. Okay, so that is important when you are actually building your big data applications. So always remember, even if your development is on small data set, but you have to be very, very clear. Tomorrow, I might get terabytes of data. So your code should work accordingly, right? So let us see the first example on how to write our simple word count example using Spark that we have installed in Windows yesterday. So I'll go back to my screen now. Okay, so we are back to our Windows machine, right? And let us do first launch our Spark cell. So you'll just say Spark cell, and this will give you a Spark cell. Okay. Now let's go back to our documentation and we'll follow along with the notes. Number one, create a file, say D dataset word1.txt. Okay, location can be anything, but please make the changes accordingly. Okay, so I'll create a file called word1.txt under dataset folder under D drive. Okay, so let's do that. We'll go back to our computer. Let's go to D drive. Okay, and you would not have this dataset folder by default, so I'll just delete this. And now let me create a folder called dataset. Done. Okay, now inside this dataset folder, let us create a file with the name word1.txt, and we will paste this lines. Okay, or you can just write it apple ball if you wish to. So right click and say new text document, and I'll say word one, right? Let me say double click on this, and I'll say paste. I've written all my words, and I'll just save this. Done. Okay, so I've just saved this file. Now please make sure that you don't make a mistake like this. Let's say new text document. Sometimes few of you make a mistake like this, word1.txt. The moment you write .txt, this is actually word1.txt.txt. Okay, and then your code would not work. It will say file not found because you have written word1.txt. Don't write word1.txt here. Okay, so if you created a file, the file extension by default is text document. If you create a file like this, new text document, that will give you the extension of .txt by default. So don't make this mistake. Okay, so I'll just delete this in some time. Okay, so we have got word1.txt. Now let me also go back and delete my output folder. Okay, now let's go back to our notes. So the first thing that we have done is created our file. All right, now as I've said, please make sure the file is word1.txt and not word1.txt.txt. Okay, take care of this. Next, let us start our Spark cell. We have already launched our Spark cell. Okay, so we will fire this command spark-cell to run our Spark. We can also run our Spark in a master local mode with this kind of configuration. We will see this in the coming lessons. Okay, now what is the very basic building block of Spark, guys? Do you remember we talked about that? Like whenever you say you know Spark, there is something which is the very basic fundamental block of Spark, that is your RDD. Okay, RDD, right? So the first thing that we would do is create a RDD from your input source. What is your input source in this case? A text file. Okay, and how do you create the RDD? You'll create the RDD using SC object. So let us see what exactly it is. So we'll go back to here and let us go back to our terminal. Now in this terminal, do you see that it says Spark context is available as SC? That means when you are in this terminal, okay, you can use SC as a Spark context. What is a Spark context? We will talk about that in great detail in the coming days. I just wanted to get started with the first practical example, right? So whenever you want to work with Spark, you need to create a RDD, and to create RDD, you need SC object, a Spark context object. If you are trying to launch a Spark in terminal like this by using Spark cell, SC is by default available to you. Spark context is by default available to you as SC object. Okay, so our code would now be this: sc.text file, and give your text file location, and it returns you an object. Okay, and this input is basically your RDD. So let me copy this and say paste. Now this is your RDD. There is a question, but these days no one uses RDD for transformation. Instead they use data frame. Is it right? You are absolutely wrong, my dear friend. So this is your RDD. Okay, sc.text file. So the moment you do this, you have actually created a RDD out of the data set. Okay, out of your input file. So there are so many other things that you can do on this SC. Right now we will be limited to only creating one RDD from text to file. Okay, and that is how you will do, right? So sc.text file will create a RDD for you. Now what is this input? Check it out. This input is of type RDD. Of what string? Why string? Because this word1.txt contains words. It contains data of string type. Okay, hence this is basically a RDD of string type. Okay, this is RDD of string type. All right, now look into this. We have created a file called word1.txt, and let us say the content of this file is this. Now if you see, this is a complete line which is a string. This another complete line which is a string. This is a complete line which is also a string. Okay, now when you say sc.text file, right, and you pass this path, let's say d drive data set word1.txt, what you get is you get an RDD. You'll say, well, right, you get input. You can write, you can also write word RDD, something like this is also fine. I've written input, but it is actually an RDD. So when you do that, what happens, it creates a RDD. This will create a RDD and returns you back a RDD of string. In my case, this word1.txt is a very simple file. But what if this file is of, let's say, 200 MB? If this file is of 200 MB, then internally what will happen? This will be broken down into two pieces. Let's say 128 MB and 72 MB. Okay, and let's say these two pieces are like this for our simplicity. This first piece and this second piece. This is present in machine 1. This is present in machine 2, right? So, but when you say sc.text file, it does not matter where it is. I'll get the RDD of string. Whatever I do, those logic would be executed here on machine 1. The same logic will also be executed in machine 2, right? In my case, there is a single data altogether, because the size is so limited that it will not be divided into two pieces. But we will see that those kind of examples also going forward. So we got an RDD of string, right, which means it is basically a RDD of strings, and your first string is apple ball. If I go by this example, next one is apple, and the last one is ball. Okay, this is how the data is broken down. So this is what has happened internally. Okay, now let's say Control L to clear the screen, and now we'll go back to our next line now. Okay, now whatever you have created, let us try to see what exactly we have created is converted to RDD properly or not. So in that case, you can say input dot collect. Okay, so this input dot collect can be useful to know what is the data right now in input dot collect. So when you do input dot collect, what it has returned you is, it has returned you an array of first line, second line, third line, fourth line, fifth line, sixth line. So your input file has 6 lines. Okay, check it out. 1, 2, 3, 4, 5, 6. So they are converted. See, when you say input dot collect, it brings the data together. So when it brings the data, let us say in the real world, this data is present in node 1, this data is present in node 2, this data is present in node 3, this data is present in node 4, this data is present in node 5, this data is present in node 6. Possible, right? So it brings all the data together and shows you in form of your array. Okay, now the best way to understand this RDD is like a collection of data set, a collection of data altogether, right? So can I assume the RDD looks like an array of objects, wherein the first element is this, the second element is this, the third element is this, and so on. Okay, now let's go back. So we just wanted to see what we have. Okay, now either you can write input dot collect. So let me go back to here. So either you can write input dot collect, or you can write it like this, or you can also try writing like this. Right now, if you see, we have launched Spark Cell, and that has given us a Scala prompt. Okay, now whatever you are doing, all these are actually all Scala code, right? So this is all your Scala code. Let's go back. So we have done this. Now the next thing that I would like to do is, I would like to split my lines, okay, by space. See here, we have got apple ball, apple ball. So I would like to split this data now. Okay, so for that you will start writing some code, and we call those code as transformation. So check it out, the next line. The next line we have written input dot flat map. Okay, I'll explain you what this flat map does, right? So let me first execute this piece. So what is your input? Input is basically this array, right? RDD, to be very honest, RDD. Okay, input is basically an RDD which looks like an array which contains all these elements. Now you are saying input dot flat map line. So this flat map is a function that will iterate on every line, and every line's data you will get here. First time line value would be this, second time line value would be this, third time line value would be this, fourth time line value would be this, fifth time line value would be only apple, sixth time line value will be just ball. Okay, now suppose if I got apple ball, so suppose I got this. Now if I get this, then I'm saying line dot split by space. So what will happen, this will be converted, this line dot split will also return you back an array. So this will give you an array back. Okay, now let me do this. I'll say words dot collect. So what I've got is, I got apple, ball, apple, all this. So let us understand what has happened internally. Okay, so I'll go back again. So let's understand that part, right? So we had created our RDD. We just said, well, input is equal to sc dot text file of d colon data set slash word1.txt. This we did already, right? And this word1.txt means a file with apple, ball, let's say apple, ball, something like this. Now our next code is convert this into single unit. Okay, so this will give me what? This will give me RDD of string. This will give me RDD of string. This input is basically RDD of string type, and that means this input, one line holds both, the entire line, apple and ball. Next line holds apple and apple. Third line holds ball. So I should separate them. So what I'll do, I'll write a code like this. Input, which is my RDD, dot, let me do map. Okay, first I'll do map. When you say map, that means for each line. Okay, when you say map, that means for each line. So I'll get line here. So first time, what is the value of line, guys? I want you to answer this. First time, what is the value of line based on this data set? What would come up in this line? I said input dot map of line. So this line will hold what value? This line will hold apple ball, right? So the meaning of line is now apple and ball. So what I want to do, I want to split them. So I'll say, okay, line dot split by what? Space. There is a space between two words. So I will say split by space. So whenever you use split, that will give you an array. That will give you back an array. Okay. So what you'll get is, you'll get an array here. I'll say well ARR. Okay. Now if I return this array back, because you know that maps should return back something. Okay. If I write something like this, then what will happen? This array, this input is broken down into pieces, and you get the next value. I'll say, well, let's say temp, TMP. Now this temp will hold what? This temp is another RDD, because you're doing a map. So this will be another RDD, okay, which will hold apple, ball, then it will hold apple as an array, then it will hold ball like this. It will hold the data like this. And this is what you don't want. You want to make sure that these are not put inside your array. Okay, for that you'll use a flat map. So what this flat map does, if the map is returning back an array, it is returning me back an array, it will unbag it, which means if you use a flat map, then this would become like this. This would become like this. If you use flat map, then the output would be this. If you don't use flat map, then the output would be this. I'll show you that practically. Okay. So this will help you to understand how the data is actually divided. Okay. So look into this. I said input dot flat map line is equal to line dot split. I just said line dot split. So what will happen? This will result me in an array. Okay. This will result me in an array, and because of that, array would be returned back. But since I've written a flat map, that array would be extracted. And since the array was extracted, you got the data like this. Let me show you something like this. I'll just remove my flat. I'll just say map. Okay. And let me say word 1. I'll just say words 1. Okay. Input dot map line dot split. Now when I do so, I got words 1. Let's try to collect this. Now see here. What you got is, for this line, apple, apple ball, you got an array of apple ball. For this line, you'll get an array of apple ball, array of apple ball. Again, for this apple ball, you'll get array of apple ball, and so on. So when you say map and when you say split will give you an array, right? So you are returning back an array, but this is what you don't want. What you want is you want to extract that bag also. You want to extract that array as well. It's something like this. Say you have a birthday party and a lot of friends have given you a gift. Mostly all the gifts are wrapped and given it to you, right? And let us say you have a container, you have got a big container wherein you have kept all the gift as it is without opening them, right? So if you look into that big container, what you have is you have small containers. Each container means the wrapper of the gift, right? Now you would really not like to keep it that way, right? So probably what you'll do, you'll remove the wrapper from all the gift and throw away the wrapper and only put the gift directly in that, right? So that is what we are trying to do by using this flat map. Okay, so map actually runs for every line and it returns you whatever you are trying to do here. If you say split, then it will actually split the data. The result of split is always array, so it will give you an array. But if you want to extract the content of an array, so you would use flat map here. Are we clear? When you do a flat map, you get the output like this, right? So let's go back here. See here, we did a flat map, right? And when we say words1 dot collect, we get the data like this. Okay, now explanation is here. If you just use map as shown below, it will try to give you an array of array. Since you would like to extract all the elements from inner array and keep them in outer array itself, we are using flat map. Or you could have also used flatten. So you could have also used flatten, which means, see, this one is what we did, map. This is what we did, right? And when you do so, what you get is got this, right? Now you can also do a flatten here, but remember, when you say collect, that means you have brought the data back to the driver. We'll explore this more in the coming class. And you are doing flatten on what? On the data that you have got. That means in this example, this flatten will not work in a distributed way. Are you getting my point? Whereas when you do a flat map, it runs on every individual node, and there is a big difference. Okay, this flatten is done on the result. The result could be big. Okay, whereas this flat map works on individual nodes, and that would be super fast. All right, now let us do this. Let us go back and we'll reconstruct this. Okay, so you could have also done something like this. Check it out. So earlier what we did, we said input.flatmap, and I know that I'll get a line. I said line, and then I'm saying you do this with the line, right? Now the rule of thumb is whenever you write a line here and there is a symbol like this and there is a line also here, then you can replace this with underscore. That's the rule of thumb in Scala. Okay, so that means you can actually rewrite this code by removing this, and you will see a lot of this kind of syntax in the real world. Okay, both of these would do the same thing for you. Okay, so we have done our flat map. Now let us see what is the status. What is the status after our flat map? Our status is words.collect. Now I've got apple, ball, apple, and so on all together. Okay, the next thing that I would like to do is I would like to emit one for every such word. Okay, so like I've got apple, I want to say apple 1. I got another apple, I would like to say apple 1. So for that your code would look like this: words dot, now you'll say map, because I want to do something for every word, every element here. Okay, words dot map. What you'll get word here, you'll get one word here. Okay, now what you want to do with this word? You want to emit word comma 1, right? And let me take the same variable name. I'll use count 1 per word. Okay, let me copy this piece. Okay, because I just don't want to change the variable name, so let me go back here and say paste. Okay, now see here. Well, count 1 per word equal to words dot map. And what is this words? Words means this. when you say words dot collect, you see that it has all these things. Now I'm saying words dot map. That means for every element on this words, that is apple, 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 ball and all, just give me back that word and one. Next word one, ball one, apple one, and so on. Okay, and I'm assigning it to another variable called count one per word. Done. So if you see this count one per word, it is also an RDD. Check it out. This is also an RDD, but this time this is RDD of string and integer. String is because you got apple, and integer because you got one. Okay, so if I want to know what is the status of count one per word now, so just say count one per words dot collect. What you can expect is apple one, ball one, apple one, ball one, and so on. See here, apple one, ball one, apple one, and so on. That means for every word we have emitted that word comma one. Okay, so this is what it does. Now let us go back and we will go back to our document again. Okay, so when we said count one per word, it has started giving me apple one, ball one, and so on. And the best way to validate would be always write collect. Right now the next thing is we would like to get the count. Okay, we would like to get the count. So now I have to count these words together. Okay, now for that what I can do is I'll say, well, I'll use the same variable counts. Okay, now I'll say, well, counts is equal to count one per words dot reduce left. Okay, it says you cannot use a reduce left, reduce by key. You have to do that. So we'll say reduce by key. Okay, now what is the status of count one per word? It was apple one, ball one, apple one, ball one, and so on. Okay, now when you say reduce by key, what it does, let's see. Reduce by key first will group the data. We'll first group the data. For example, reduce by key will first group the data like this. In this previous example, when we said count one per word dot collect, we got all apple one, ball one, and so on, right? And now when you say reduce by key, it first groups the data like this. Okay, it brings the key. This is called as your key. Reduce by key means group by key first. Okay, so it will group this key is apple, and it will collect all the values one for all the apples. So whatever one are there, one again this one, again this one, and this one, and so on. It will collect the data like this. Okay, and then we have used something like underscore plus underscore. That means these are the placeholder, which means add these two numbers, and whatever result you get, again add with this plus this one. Whatever you get, again add with this. Again keep doing this. Okay, the meaning of underscore plus underscore is that, right? So it will add everything, and then ultimately it will give you apple is present 1 2 3 4 5 6 7 times, 7 or 8 times, whatever is there in the data set. Okay, now let us say counts dot collect. Now see here, it is saying apple is present 7 times and ball is present 6 times. Okay, now this is a short way of writing this. You can actually write it in a long way like this here. Reduce by key, case, counter, next value, counter plus next value. We will explore more on this in a separate lesson. Okay, so we will understand what is reduce by key, under what condition you should write, what are the parameter that comes, how can you control all this stuff. We will talk about this in great detail in a separate chapter, but right now our intention is just to see the simple word count example. And I said accounts dot collect, and you got apple 7, ball 6. Done. Now once you are done with this, you might wish to write it into a local file. Okay, so you can do something like this. See here, counts is holding this data as a RDD. See your counts, this counts is also a RDD, which means it is holding this data. Okay, now counts dot save as text file, D drive output word count dot txt. Let me say enter. This is done. Okay, now if your winutils.exe is not set properly, then this tab will give you an error. So if you get any error here when you say save as text file, if you get a big error, that probably means your winutils.exe is not set. Okay, so that's the reason we have made it very clear how do you check if your winutils is set properly. So we have done this. Let's go back and see what is the output. So see here, in D drive, output folder is created. Okay, and let me tell you what count.txt I have written, but that does not mean it is a file. No, it is a folder. A folder will be created with this name. Okay, inside that you get a success file. If the operation was successful, you get the crc file. Okay, so this is like the checksum files. You don't have to worry about this. Your data is present here, part 00, part 0001. Okay, so your answers, your total count has happened here. So open any file and you will see some part of it. You got apple count here, and you got ball 6 here. Okay, in the real world you will be running this code on a huge data set. Okay, and they will all be created with RDDs. A lot of RDDs would be created, a lot of partitions would be created. We'll talk about that later, how the data would be distributed, and everybody would work on that data parallelly, right? The moment you say save as text file, so what will happen is one node will write it on one file, the other node would write it on another file, the third node would write it on another file, and so on. And hence you get the data here in parts. You may ask me, but I want the result in a single file. Can I still do that? You can do that. We'll see that in the coming days. Okay, right now our intention is to teach you how to write a very first word count example. Okay, now let's go back. So whatever we have discussed, they are just these lines of code. That's it. They are just these lines of codes. Okay, now let us try to do this. Now remember one thing, guys. When you try to run this code again, let's say you have said count.save as text file. If you try to run this code again, it will throw you an error. Why? Because the file already exists. It will give you an error like, see here, the output directory already exists because the directory is present. So you are supposed to either delete that directory and rerun this code, or send the output to some other file, wordcount1.txt. Okay, so which means the moment you see error, don't blame winutils. No, first go and check what is the error. Okay, the error says file already exists exception. Now do you see you are using Spark, but internally the error is coming from MapReduce. It's coming from Hadoop, the same Hadoop which you feel is outdated. Okay, the same Hadoop file output format is being used. Okay, so that's the reason I would always say you should also learn the basic fundamental of Hadoop. What is file output format? Now this is a part of your Hadoop, right? So Hadoop and Spark are internally used, even though you are not using as a programmer, but that helps you to understand this kind of errors, and this is what will set you apart from the rest of the developers. You should learn how to understand the error also. I've seen a lot of people going clueless by looking at the error. Half of your problem would be solved by looking into the error, what kind of error it is. Okay, all right, so let's go back, and now we will talk about these examples again. Okay, so in the previous example I have done collect and all, and the document became a little big, right? But if you see, the whole stuff is only this much. That's it. Okay, let us try to do this again so that you can see how easy it is. Okay, so the first thing I'll do is I'll not write anything for this. I'll copy this completely. Let me go back here. So the first thing that you have done is you had started your Spark, and when you start your Spark, you get Spark context object, and using this Spark context object you can create a RDD, which means sc.text file will give you an RDD, and you will point to which file you want to get the data from. Okay, which file you want to process. So I got input. What is this input? This input is basically a RDD. See here, it is basically an RDD. Okay, whenever you say RDD, close your eyes and say this will be processed in parallel. Okay, which means you will get the advantage of parallel processing. Okay, now you got this RDD. Now the first thing that you will do, check what is present here. it is present like this. Now, what is your next requirement? The next requirement is to split them and get access to individual elements, right? So for that you will say input dot, if I do map, then I'll get lines, and this line dot split will give me an array split. The data are separated by space, so I'll write like this. But if I do this, and I can also say collect here to just see the output in the single line. Okay, what am I going to get? I'm going to get this. Okay, is this what I'm looking out for? No. All right, so what is that you are supposed to do? Probably you're supposed to do a flat map here. So flat map, let's see what happens if I do a flat map on this. So if I do a flat map, yes, this is what exactly I'm looking out for. So I can say this is what I'm looking out for, and now you change it to another variable, assign it to another RDD. Well, I'll say, let me use the same term, okay, because I don't want to miss the term. Awards done. Now if you see, my input dot collect is this, right? When I say input, my input contains data like this. When I say words, what is my words is this. So do you agree with me that I have converted the data from one form to some other form? Yes, my original data was in some other format. The original data was in this format. Now, after doing some operation, I was able to convert the data into some other format. What is the format? I splitted them into multiple pieces. Okay, and what is this process called, guys? What is this process called when you convert the data from one format to another format? We had discussed that in our last class. Transformations. Yes, it's called as your transformation. Okay, so all these are transformations. Like when you say map, it is a transformation. If you say flat map, it is also a transformation. Okay, all right, now let us do this. We did this. Now the what is the next step that I want to do next? I'll just say words dot collect to see where am I in terms of data. Okay, I'm here. Now my next job is to convert that into apple one, ball one, and so on. So for that, again I'll say, well, count one per word, something like this, right, is equal to words dot map. I'll get word and I'll send back word comma 1. I missed this. Done. Now again try to say count one per word. Okay, per word dot collect. Okay, so if you see, we got back some output. Okay, now see here, when you do a collect, are you getting an RDD back? No. When you say collect, are you getting an RDD back? No. Check it out. I'll say well X. See here, I did a collect, but that collect did not give me an RDD back. What is this X? Is that an RDD? No. So what is this? If it is not RDD, that means this collect operation is never a transformation. Remember, a transformation will always give you back an RDD object. Okay, which means it is an action. Okay, so all right, so we did till here. All right, okay, that's fine. Now the next thing is we have got count one per word. Okay, that means apple one has come. The next thing that I should do is, now I should group this data by word and start counting those ones, right? So for that you will say dot reduce by key. That means the data is grouped. I have got apple and I've got all the 1 together, and on that value I would say this, and let me give a name, well, word count. Right, now let me say word count dot collect. So I got my answer perfectly. Okay, so you should be at least this much confident to write this simple code. This is not at all difficult. In the day one it might look a little difficult, but start working on it, execute this couple of times, and you should be all good. So this is what you would do. Okay, now the complete word count is actually only the below piece of code. That's it. Now if you are supposed to write the same code in MapReduce, you have to write a mapper code, you have to write a reducer code, and then send the data to and fro and get those things done, right? And to be very honest, in Spark also the same thing happens, but the only point is, from the developer point of view, you have put them together. Okay, all right, so let us do this. Since this is all a code, let me copy this. Okay, and I will save it in a folder with .scala extension. So let me go back here. Let me go to my D drive. Okay, so I'll just delete this folder file. Let me say new text document, paste. Okay, so this is a code. Now I have pasted this. Now I'll say file, I'll say save as. Okay, in my D drive I want to save this as word count. Let me use the same name that I have used here, word count spark.scala. Okay, now while saving it like this, please make sure you give this double quote, otherwise it would be saved as .scala.txt. Make sure that you give this as double quote. Okay, surround this by double quote. So say save and you can close this. Now what you see is you got a .scala, and more importantly, look into this type is Scala file. If you don't give that double quote, then it is possible that it might be stored as a text document. It might become word count -spark .scala.txt, and then you will have again trouble, right? So this is a small Scala file, and we have written it as a script. We have not written a main method, we have not written anything else in a Scala file. We have just written it as a script. Okay, now if you have a script like this, then you can actually do something like this. I'll go back here, I'll quit this terminal. Now let me say spark cell -i d word count.scala. Okay, this is another approach to launch your Spark cell and execute this script present in your Scala file. So just wait for some time. What it will do, it will actually log into Spark cell. It will start reading all the content of this Scala file and will start solving. Okay, but before that, let me delete my output folder. Before that happens, I'll say delete. Done. I've deleted my output folder also, so that while writing the data to the output file, I should not get a problem like the file already exists. Done. See here, I've executed this piece of code. It logged in, it did its job, and it came out of this. Let's go back to our output folder. Let's see we have something. Yes, the output folder is recreated. Go back here, go here, okay, and you will see the output is written successfully. See here, apple 7, and likewise go to the next file. It will give you ball and the number ball 6, right? Now let me do this. Let me try it again. Now this time the file already is present. I have not deleted the file, which means it should throw me an error like the path already exists. Okay, now let us see what happened here. Okay, see here, it says file already exists exception. I got this exception, and because we got this exception, the control is not out of the Scala. Why? Because if you see here, when I execute this program second time, this will work, this will work, this will work, this will work perfectly. Okay, but there would be a problem at this stage. And what is that problem? That is an exception. And the rule of the programming language says if there is any exception in any code, then it does not go to the next line, right? And because of that, your code terminated here itself. Because of that, we did not get a chance to call system.exit, which would have actually taken us out of the Spark cell. Okay, and because of that, if at all you get an error in these steps, the control would still be there. And if you want to avoid that, you have to write a try, catch, finally, and all, and put this system.exit in the finally block, so that finally it gets out of the script. Okay, cell. All right. Now you can also do something like this. What if you wish to run the file from Spark cell itself? Okay, if you want to run the code from Spark cell itself, then you can do something like this. Check it out. So what I'll do is, let me say quit. Okay, I'll go to my D drive where my script file is present, and I'll launch my Spark cell from here. Okay, and let me go to my D drive, and here I have this file. Let me edit this file. and let me remove this system.exit. Save. This is saved, and let me delete this output folder as well. Okay, Control L. Now let us see this. What if you wish to run the file from Spark Shell itself, right? Which means first you remove system.exit and get into Spark Shell. From D drive, I would say execute the below code. So you can just say load and the file name. What is the file name? The file name is this. So make sure that the file name is perfect. So just let me go a little down and let's see. The file name is small word count hyphen spark dot scala. Now see here, it has started reading the data from that file. It will execute, it will write the data into the output file, but you are still inside your Spark cell, right? So I've shown you how to run the script if you are inside the cell or if you are outside of the cell. Okay.